Welcome to notes number 5 on zero and negative exponents. We've had in class a couple occasions where it's come up that we've had an exponent of 0 or maybe even a negative exponent, and we've really glossed over it and not talked about what that means. So today in our notes we're going to see using some tables and examples and patterns to see what it means to have a negative exponent or to have a zero exponent. So let's get started and take a look at number 1. It says use the power of a quotient property to simplify each expression. Write the quotient as an exponent. So here the first expression is 3 to the 5th divided by 3 squared, and it's equal to 3 to the 3rd because we're going to subtract the exponents. In the second example, 3 to the 5th divided by 3 to the 3rd is equal to 3 to the 2nd power. In the next one, 3 to the 5th divided by 3 to the 4th is equal to 3 to the 1st, because I'm going to subtract the exponents again. And then the last one, 3 to the 5th divided by 3 to the 5th is 3 to the 0 power. So what expression did we write for the last one? Well, the last one is equal to 3 to the 0 power. And we used an exponent of 0. So let's take a look at what that might mean. So in question number 2, it says, using factored form, find the value of 3 to the 5th divided by 3 to the 5th. Well, that just means if we multiply it out, 3 times 3 times 3 times 3 times 3, divided by 3 times 3 times 3 times 3 times 3. And if we multiply this out, you can use a calculator to multiply it out, the numerator comes out to 243 divided by 243. Now you know when you have any number divided by itself, it's equal to 1. It goes into itself once. And even if we use another method where you think about canceling numbers, here 3 divided by 3 is 1, 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 3 divided by 3 is 1. You're just going to have 1 divided by 1, which again is 1. So either way that you do it, you come out to an answer of 1. So in question number 3, it says, based on your findings, what can you conclude about the value of 3 to the 0 power? Well, it probably indicates to me that 3 to the 0 power is going to equal 1. So for just a moment, let's take a look back at the table, and I want to take a look at why that might be. Okay, so let's go back to the exponent 3 to the 3rd power. 3 to the 3rd power means 3 times 3 times 3. And if you multiply that out, that's 27. 3 to the 2nd power, you know, is 3 times 3, which is equal to 9. 3 to the 1st power is just 3. So what is the pattern that we see happening here? Well, as we go down the table from 27 to 9, you're dividing by 3. And from 9 to 3, again, you divide by 3. So if we're going to continue this pattern, 3 divided by 3 is going to equal 1. So 3 to the 0 power is equal to 1. In fact, anything to the 0 power is going to equal 1. If you look down on your notes here, it says number 4, make a prediction about the value of any number raised to the 0 power is going to equal 1. So any number raised to the 0 power will equal 1. And give this a shot with your calculator. If you have a calculator in front of you, you can try numbers raised to the 0 power and see what it's equal to. Here I've brought up a scientific calculator, and so let's try this here. I'm going to do 6 to the 0 power So here I brought up my scientific calculator. I'm going to try some problems. I'm going to do 6 raised to the 0 power, and it gives me 1. How about 9 raised to the 0 power? I get 1. How about 18 raised to the 0 power? I get 1. Let's write a big number. How about 999 raised to the 0 power? We get 1. So no matter what number you try as a base, any non-zero number raised to the 0 power is equal to 1. So let's write that into our notes. It's going to be equal to 1. So any base, as long as it's not 0, raised to the 0 power will equal 1. So now what I'd like you to do is turn to page 12 and use that idea that anything to the 0 power is 1 to help us simplify the following expressions. So please now press pause for a moment and try questions 6 through 9 and use that idea that anything to the 0 power is 1 to help you. Press pause now. So now please check your answers and see if you have the same answers as I do here. Let's take a look especially at number 7. In number 7, 3 times 10 squared, you can follow order of operations and do the multiplications first. That's just 3 times 100. This is 2 times 10. 8 times 10 to the 0 is just 8 times 1. 10 to the 0 power is 1. This probably should look familiar. This is place value. So we have 3 hundreds, which is 300, 2 tens, which is 20, and 8 ones. So this is a total of 328. And then in number 8, it simplifies to 4 to the 0 power, which we know is just 1, because anything divided by itself is 1. Okay? Now let's take a look at question number 10. Use the quotient of powers property to simplify each expression. Write the quotient in exponential notation. So we're going to do it just like we did at the beginning of the notes. So the next one, 4 to the 5th divided by 4 to the 4th, is just 4 to the 1st power. 4 to the 5th divided by 4 to the 5th is 4 to the 0 power. 4 to the 5th divided by 4 to the 6th is 4 to the negative 1 power, because 5 minus 6 is negative 1. And then finally, 4 to the 5th divided by 4 to the 7th is going to be 4 to the negative 2 power. I know this looks a little bit unusual, but let's take a look at what these might mean by using some of these patterns. What expression did you write for 4 to the 5th divided by 4 to the 6th? So we wrote 4 to the negative 1 power, and the exponent we used was negative 1. And so let's look at what this means in factored form. Well, this means 4 times 4 times 4 times 4 times 4 divided by 4 to the 6th. So when we go ahead and cross cancel these, 4 divided by 4 is 1, this is 1, this is 1, this is 1, this is 1. So in the numerator, everything cancels, so we just have left 1. In the denominator, we have 4, 1 times 4. So this is equal to 1 divided by 4, or is just 1/4. So 4 to the negative 1 power is equal to 1/4. Question 12 asks us to do something similar, except 4 to the 5th divided by 4 to the 7th. So again, we're going to write out what we would do to multiply it out, divided by 4 to the 7th. So when we go through and cancel, 4 divided by 4 is 1. This divides out to be 1. These all simplify to 1. So in the numerator, again, we have 1 the number 1. In the denominator, we have 4 times 4. So this is 1 over 4 times 4, which we can write as 1 divided by 4 squared, because we know that 4 times 4 means 4 squared, or you could write as 1 divided by 16, or 1/16. So we see here that 4 to the negative 1 power is equal to 1/4, or 1 over 4, or 1 over 4 to the first. When there's no exponent, you know that that means 1. 4 to the negative 2 power is equal to 1 over 4 squared, or 1/16. So it looks like that when you have a negative exponent, it does not mean that the answer becomes negative. Not at all. It means that you take the reciprocal of the base. Okay, let's go back up to the pattern in the table to see what's going on. Let's take a look at the table again here. When we have 4 squared, we know that this means 4 times 4. When we have 4 to the first, we know this just means 4. And then, so as you're going down, you're dividing by 4. So this is 16 divided by 4 is 4, and we learned that 4 divided by 4 is 1, that 4 to the 0 power is 1. As we go down the column, as we're working down the column, we're dividing by 4. As we move down the column, we're dividing by 4. So 16 divided by 4 is 4. 4 divided by 4 is 1. So we would continue this pattern. We're going to divide by 4 again. And you know that a way of writing divided by 4 is by saying 1 divided by 4th, by 4. And then we're going to divide by 4 again. So if we repeat that, we have 1 divided by 4, and then divided by 4 again. So we're going to have 4 multiplied twice in the denominator, which is equal to 1 over 4 squared. So anytime you have a negative exponent, it does not mean that the answer becomes negative. It means that you take the reciprocal of the base. Another way of saying taking the reciprocal is you flip the base. Instead of 4 being in the numerator, it becomes in the denominator. So if we look down here in the box, it says a raised to the negative n power. So this does not mean that the answer becomes negative. It means instead of using a in the numerator, it's going to be 1 over 1 divided by a to the n power. So a negative exponent tells you to take the reciprocal of the base. You flip the base, and then the exponent is now positive. So this means anytime you have a negative exponent, let's say you have a fraction. Let's say you have the fraction 2/3. So this means anytime you have a negative exponent, it tells you to take the reciprocal of the base. So for example, let's say we have the fraction 2/3. So anytime we have a negative exponent, it tells us to take the reciprocal of the base. So for example, let's say we have 2/3 raised to the third power, negative third power, excuse me. That the negative 3 power does not mean that the answer is going to be negative, not at all. It just tells us we're going to take the reciprocal of the base. So instead of 2/3, we're going to have 3/2. You flip the base, and then the exponent is positive. So 3/2 to the third power just means 3 over 2 times 3 over 2 times 3 over 2. 3 times 3 is 9, times 3 is 27, 2 times 2 is 4, times 2 is 8. So anytime you have a negative exponent, you simply take the reciprocal of the base. So at the top of page 13, we see question number 13, how would you write a to the negative 3 using a positive exponent? So to rewrite that, the negative exponent tells us to take the reciprocal of the base. Well, the reciprocal of a is 1 over a. So now this becomes 1 over a to the third power. You can write it like that. You can also write 1 over a, 1 like this, 1 over a to the third power. They are equivalent. Now I'd like you to try answering questions 14 through 21 on your own first. Remember, it just says to simplify each expression. Write your answer using a positive exponent. So here, each time you're going to simplify, remember to rewrite your answer using a positive exponent. So first, simply simplify the expression using the rules you already know. When you multiply like bases, you're going to add the exponents. Then if you end up with a negative exponent, take the reciprocal of the base so you can rewrite it as a positive one. So please go ahead right now and press pause. Try questions 14 through 21, and then you can restart the video to check your answers. Okay, so please go ahead and check your answers now. And I did show my work. Especially check, for example, in number 15. If you end up with an answer that says x to the negative 11 power, you want to rewrite that as 1 over x to the 11th. In number 16, I rewrote the problem so it's vertical. I find it easier to see, so you can divide the numerators, divide the coefficients and then divide the variables. And then in number 17, I showed my work how I subtracted the exponents. I ended up with negative 3, and then the negative exponent tells me I have to take the reciprocal of the base. So it's 1 over x cubed. Questions 18 and 19 involved a couple more steps. So in number 18, inside the parentheses is my base, and I'm raising all of this to the negative 1 power. So what I did is I took the reciprocal of the base first, and once you take the reciprocal of the base, then your exponent becomes positive 1. Instead of negative 1, it's positive 1, because I already flipped the base. And then I simplify the numerator, once I take the reciprocal of the base, I can simply simplify the interior. 32 divided by 8 is 4. N to the 0 divided by n to the 5th is n to the negative 5 exponent. So because this exponent is negative, it tells me this has to be in the denominator. I take the reciprocal of n, which is 1 over n to the 5th. So the 4 stays in the numerator and the n is in the denominator. Same thing in number 19. I simplified what's in the parentheses first. Then I divided them. I wrote it vertically and I divided them. I ended up with 1 times a to the negative 2 power. A to the negative 2 power tells me I have to take the reciprocal of the base, which is 1 over a squared. And then finally, number 20 and 21. I simply used the power and quotient rules. Here, when you divide like bases, you subtract the exponents. I ended up with negative 6 to the negative 1 power, which tells me I take the reciprocal of the base, which is just 1 over negative 6, or negative 1/6. And then the same thing in number 21. I simplified the numerator, I simplified the denominator, but since each exponent is negative, since the 3 was in the numerator, it ends up in the denominator. Since the 5 was already in the denominator and its exponent is negative, it puts it in the numerator. Because in essence, this is 1/5, it puts the 5 in the numerator then. Okay? We will practice more of these examples in class. And as always, if you have any questions, please bring them to class and we'll go over it then. Thank you.